Welcome to homework.
Here we're given that the maximum lead concentration in a sample of water is 9.0 parts per billion. ppb stands for parts per billion. We're asked to convert this concentration into a molarity. So if we have 9.0 parts per billion, then that means that if I had 10 grams, if I had 10 to the 9, so this is a billion, 10 to the 9 is a billion. If I had 10 to the 9 grams of water, of those billion grams of water, I would have 9.0 grams of lead. That is my concentration. Okay. Now recall that we're going to assume that this density of water, this water is 1 gram for every milliliter. So if I have 10 to the 9 grams of water, that means that I have 10 to the 9 milliliters of water, which is equal to 10 to the 6 liters of water. Okay. The reason that'll help me is because my 9 grams of lead and my 10 to the 6 liters of water are going to help me find the molarity. Okay, so I'm going to set that aside. Recall that molarity requires moles of solute. So I'm going to use the molar mass of lead. I'm going to look that up on the periodic table. So I'm going to change my 9.0 grams of lead to moles by dividing by the molar mass, which I get from the periodic table, 207.2 grams of lead for every 1 mole of lead. And then I find that this is 0.0434 moles. Again, I chose this random water sample because it was easy to work with. I already had all the information about it. So if this is my moles of lead, and I know how many liters of water I have, then I can write the molarity as 0.043 moles, 0, divided by 10 to the 6 liters to give me a concentration in scientific notation of 4.34 times 10 to the negative 8 molar, and that's my lead concentration. In part B, we're asked if I had a 60 meter cube sample of water, how many grams of lead would that be? So let's start with some conversion factors. 1 meter cubed has 1,000 liters. And so if I have 60 meters cubed, that corresponds to 60,000 liters. Okay, so I know I'm working with 60,000 liters. Now I'm going to use the concentration that I found in the part A. So I know that 4.34 times 10 to the negative 8 molar is the concentration. I'm going to work with that and say, well, if I have a concentration of 4.34 times 10 to the negative 8 molar, I'm going to write that as moles for every liter. This is the same thing as capital M. I'm going to multiply that times the volume that I have, 60,000 liters. Notice that my liters cancel, and I find that this is equal to 0.0026 moles of lead. Fantastic. So if I have moles of lead, then I can change moles to grams by multiplying times the molar mass. So the opposite of what we did earlier. So I'm going to take my 0.0026 moles of lead, multiply by the molar mass. So that's the 207.2 moles. 0.2 grams for every 1 mole. And find that this particular sample of water would have 0.54 grams of lead.